All right, this is grade 6, unit 2, lesson 16. And in this lesson, let's see, we are going to be, oops, what? There we go. Bam. Oh my gosh, what a mess I am. Okay, and in this lesson, lesson 16, we're going to be solving some more ratio problems. And basically, we're going to be using choices, giving students a choice between double number lines, tables, and the new tape diagram idea to solve ratio problems. And so, you know what? Let's just get started. And so there we go. All right, so we're going to start with a nice warm-up problem here. And the warm-up problem, let's see, right there. No, that one. All right, the warm-up problem is talking about you tell the story. All right, so it says describe a situation with two quantities that this tape diagram could represent. So the idea is we have 1, 2, 3, 4, 5, 6, 7 to 3. So we have a ratio of 7 to 3. And but each of those units represents 3, so that's really 21 to 9. So we have 30 things. I mean, there's a whole lot of ways we could tell this story. We would have to include the number, maybe the number 30. We might include the numbers 21 or 29. Heck, we could even include the number 12, as in there are 12 more of this than there are of that. So 12 more of this than there are of that. And so, I mean, we could do a whole host of stories as long as our story satisfies this picture. So I'm not even going to steal your joy, parents and teachers, of watching the students as they kind of think about what stories could that picture be telling. So there you go. So number 2, next activity, a trip to the aquarium. Consider the problem. A teacher is planning a trip to the aquarium. It requires 2 chaperones for every 5 students right there. And the teacher plans accordingly and orders a total of 85 tickets. Now, the question would be, how many tickets were for the chaperones and how many were for the students? Now, we could solve this problem in one of 3 ways, but I'm going to show all 3 ways. We have a triple number line. Down here, we can look at it as a table, or we can look at it as a tape diagram. So let's dig into each of these. All right, so right here with our triple double number line. If you have 2 chaperones, 15 kids, that makes 17 people. And so we can say, all right, if we have 4 chaperones, that means we need 30 kids, and that's 34 people. We could say 6 chaperones is another 15, so that's 45, and so that's 51 people total. If we have 8 chaperones, so that's another 15 kids, so that's 60, so that's 68. Let's see, did I do that right? I think so. And then heck, we can have another 10, another 2, so 10 chaperones is 75 kids. And hey, look at that. There is our 85, and that is our, I don't know, magic solution right there. So how many tickets were for the chaperones? 10. And then how many tickets were for the kids, the students? 75. And there's our 85 total. So that's what it looks like with a triple number line. We could do the same thing with table, something similar. We could say, well, if we have, let's see, 30 kids, so that means we need to have 4 adults, meaning if we add 15 additional kids, we add 2 additional chaperones, and we have 34 people total. If we add another 15 if we add another 15 students, that means we're going to add another 2 chaperones. So that gives us 51 people total. And we could continue doing this. 60 is 8, and there's 68. Add another 15 kids, add another 2 adults, and there's our 85. So that's a way for us to represent that solution method using a table. And then the last one is using a tape diagram. So the idea is we have a ratio of 15 to 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 kids to 2 chaperones. And that has to be a total of 85 people. So these 17 units is equal to 85 people total. So that means each unit must represent 5 people. How did I do that? I did 85 divided by 17, and that's how I got my 5. So that means each of these units must be a 5. So when I fill in all of these 5s, of course, I don't have to fill these in. I can see easily that there's 10 adults, and this is 15 units. So 15 times 5 gives us 75. So that's 75 kids. All right. So after we solve these things, the idea, parents and teachers, is to allow students choice. Choice as in, do they want to attack this with a number line? Do they want to attack this problem with a tape diagram? Or do they want to, a table? Or do they want to attack this with a tape diagram? And really, it's all about choice and allowing students the opportunities to choose and really own the math themselves. And so talk about why do they prefer one versus the other, because it's totally legit, whatever their choice is. All right, now, moving forward, this is kind of a neat one. Teachers, don't shy away from this. This is a beautiful open middle type of example of type of problem. It's really kind of fun. So give it a try. Find some time to bust this problem out and let students work on it. So 16.3, activity number 3, salad dressing and moving boxes. We could solve this using kind of like an information gap attack activity, but I'm gonna just walk us through each of these problems. If I get stuck, I'm thinking out loud, if I get stuck, I am going to use either a number line or a table or a tape. Let's see what happens here. So it says a recipe for salad dressing calls for 4 parts oil for every 3 parts vinegar. How much oil should you make to make a total of 28 teaspoons of dressing? So in this case, I see a part, and a whole. I'm going to use a tape diagram because I kind of like it. So I have, let's see, I have oil and I have vinegar. Oil and I have vinegar. And I see that ratio is supposed to be 4 to 3. So I'm going to zoom in and say, all right, here's your 4 units for the oil. And here's your 3 units for the vinegar. And all together, I want this to be 28 teaspoons. So I can see that I have 7 units that are supposed to represent 28 teaspoons. So that means each unit is 4. So I can go ahead and fill in each of these as a 4. And it says, how much oil should I use to make a total of 28? Well, I can see that I need 16. I have 4 units of 4, so I need 16 teaspoons. 16 teaspoons of oil. There you go, right there. All right, moving down to question 2. Andre and Han are moving boxes. Andre can move 4 boxes every half hour. Han can move 5 boxes every half hour. How long will it take Andre and Han to move all 72 boxes? Oh my goodness. Let's see. Well, I can say, I think what I would do. What would I do? I could do a number line, table, or a tape. I think I'm going to do on this one, let's do a tape. All right, and we'll make it a triple tape diagram. So we've got Andre. Did I say tape diagram? I meant triple number line. Andre, Han, and total. All right, and so I'm going to make our triple number line like this. And I can see that in a half hour, so each notch is going to represent a half hour, let's say. And I can say, well, no, let's do an hour. We could do it in an hour. So in 1 hour, let's see, Andre is going to move 8 boxes. And Han is going to move 5 boxes. In an hour, Andre is going to do 8 boxes because it's half hour. 4 is a half hour. And Han is going to do 10. So in 1 hour, let's do it in blue. Andre is going to do 8. Han is going to do 10. And that's a total of 18. And that represents 1 hour. And then if Andre does another 8, so that's 16. That means Han will do another 10, which makes it 20, and that gives us 36. And I'm going until I get 72. So I'm not there yet. So let's do another hour for Andre. So he's up to 24. Han is up to 30. That means we are up to 54 total. And we're not quite there, so let's do another one. So that's 32 for Andre, 40 for Han, and 72 for the total. And that's exactly what we want, isn't it? And so we can see how long will it take? Well, it took us 4 hours to do that because here was 1 hour, 2 hours, 3 hours, and 4 hours to move those 72 boxes. This was a really, really powerful lesson where students are given the choice between solving a problem using tapes or number lines or tables. And that is just so empowering to allow students the opportunity to have ownership over the math instead of the math having ownership over the students. So let's do our practice. Let's do a quick look at our practices. It's been about 12 minutes so far. Describe a situation that could be represented with this tape diagram. Well, this is another kind of creative problem. We've got a ratio of 3 to 2, or we could say 18 to 12. Let's say we have dogs and cats. And we have a total of, let's see, 1, 2, 3, 4, 5, 30 animals. So we could say a veterinarian, yeah, sure, has 30 animals in her vet. They are all dogs or cats. So she has no llamas or anything or chickens or something. They're all dogs or cats. They are in the ratio of 3 dogs for every 2 cats. How many of each are there? All right, and that's an example of what your story could be. Does it have to be about that? Does it have to be about cats and dogs? No, it's just that's what I chose to do. Oh, golly, come on, I want you to shrink. Let's go here, people, shrink. There we go. Nice. All right. Number 2, there are some nickels, dimes, and quarters in a large piggy bank. For each 2 nickels, for every 2 nickels, there are 3 dimes. So that's important. For every 2 nickels, there are 3 dimes. For every 2 dimes, there are 5 quarters. There are 500 coins total. Oh my goodness. How many nickels, dimes, and quarters are in the piggy bank? Explain your reasoning. Wow, this is a good one. So for every 2 nickels, there are 3 dimes, but for every 2 dimes, there are 5 quarters. So what I want to do is I want to make it so that the dimes are kind of consistent here. So what I'm going to do, that 2 nickels, and I'm going to do 2n for every 3 dimes, I can rename that to be 4 nickels and 6 dimes, can't I? And then for this 2 dimes and 5 quarters, so for every 2 dimes, there are 5 quarters. Yeah, and then I can triple that, and I can get, I could get 6 dimes is 15 quarters. All right, and now all of a sudden, I got this common ratio going on here. That 6 dimes, so when there are 4 nickels, there's 6 dimes, and when there's 6 dimes, there's 15 quarters. So this idea of 4 nickels, 6 dimes, and 15 quarters, so they kind of go together. So I can do nickels, let's see, nickels, dimes, and quarters, and then total. And we have a nice, beautiful ratio right now. And that beautiful ratio is 4 to 6 to 15. So I'm going to do this in black. 4 to 6 to 15. So when there are 4 nickels, there's 6 dimes, and there's 15 quarters. So that all goes together. And for a total of 25 coins altogether. Now, if I want to know how many of each would there be if we had 500 coins all together? So my thought is, so what is our multiplication? Our multiplication would be 20, because 25 times 20 gives me 500. So then all I have to do is multiply each of these things by 20. So 15 times 20 is 300. 6 times 20 is 120, and 4 times 20 gives me 80, and there is my ratio: 80 nickels, 120 dimes, 300 quarters. That adds up to 500 coins. So how much are the coins in this piggy bank worth? Well, boy, let's see. 80 nickels is worth $4. 120 dimes is worth $12. No, yeah, $12. $12. And 300 quarters. Oh my gosh, 300 divided by 4 is 75. Okay, so that's $75. What? And then we add those together and we get 75 plus 16. What is 75 plus 16? 91. So that's 91 smackaroonies. That's awesome. All right. Number 3, 2 horses start a race at the same time. Horse A gallops at a steady rate of 32 feet per second. Horse B, steady rate of 28 feet per second. After 5 seconds, how much farther will horse A have traveled? All right, so we have a ratio here of basically 32 to 28. And we want to, well, heck, I think what I'm going to do is I'm going to make a table on this one. I like the idea of a table. So we've got A, B, and the difference between these two. All right. And so after 1 second, it's 32 versus 28. All right. So I'm going to do that in purple or whatever this color is, 32 and 28. So that's 1 second. And that's a difference of 4. If we do another second, this will have done another 32. This will have done another 28. And we will then have, I think, a difference of 8, I think. And let's see. Let's do it. So 64, 56. All we did was double it because another 32 gives you 64. Another 28 gives you 56. So now we have a distance of 8. And really what we want to know is, this is 1 second, this is 2 seconds. What are we going to do? We want a total of 5 seconds. So really, I'm going to take that 32 times by 5, and that gives me 160. I'm going to take my 28 and times by 5, and that gives me 140. And I can see that our difference is going to be 20. And that makes sense because 4 times 5 gives me 20. So 5 seconds. A will have traveled 160. B will have traveled 140, which is a difference of 20. But we could have seen that in that very first row that you just take that 4 and times by 5, and that gives us 20. All right, number 4. Andre paid $13 for 3 books. Diego bought 12 books priced at the exact same rate. How much did Diego pay for the 12 books? So we can make a nice little table here. Andre paid $13 for 3 books. So we've got dollars, we've got books, we've got 13 for 3. Diego bought 12 books at that same price. And so we want to know, what's the price? Well, 3 times 4 gives us 12. 13 times 4 gives us 52. So 13 times 4 gives us 52. So it is $52 for those books. And then question 5, a little bit of review here. Which polyhedron can be assembled to form that net right there? Oh my goodness. Well, it feels like a triangle because I see a lot of triangles. So I'm going to kind of immediately, I'm going to cross off rectangular prism. Doesn't feel like a trapezoid. So it's really either a triangular pyramid or a prism. And the key is that last word. And this is definitely not a prism. A prism is where the top and the bottom look the same. But this, the top is going to be a point and the bottom is going to be a base. So that tells us it is a pyramid. And number 6, find the area of this triangle. Show your reasoning. So what I'm going to do is immediately just go straight to a rectangle. I can see the outer rectangle. And I can see that 1, 2, 3, 4, 5 is 5 units tall, 1, 2, 3, 4, 5 units wide. So I can see that entire figure has a area of 25 units squared, but we need to remove part A, B, and C. All right, so A is 3 by 2. So part A is 1/2 of 3 by 2, which is 3 units squared. I can see that B right here is 2 units tall and 1, 2, 3, 4, 5 units wide. So it is 1/2 of, let's see, 2 times 5, which is 5 units squared. And I could see that C is 3 by 1, 2, 3, 4, 5, 3 by 5. So it's 1/2 of that 3 times 5. So that's 15 divided by 2 is 7.5 units squared. So now what I need to do is I need to add all of these and then subtract it from 25. So 25 take away, so to speak. 3 plus 5 is 8. Plus another 7 is 15, plus that half. So it's going to be 15.5. So 25 take away 15.5. Well, 25 take away 15 is 10, but then we have to subtract 5 half more. So that's going to be 9.5 units squared is our remaining blue area right there. And folks, that wraps up. Let's see, which camera am I going to be on? This one. All right, that wraps up grade 6, unit 2, lesson 16. And folks, don't forget to subscribe.